Previously on Mr. Moore's online math class, we have learnt how to factorise quadratic expressions. And in some scintillating episodes, we have learned that it's possible to use these skills when solving quadratic equations. But today's lesson, guys, is all about how to apply these skills in order to be able to sketch the graph of quadratic functions. So let's not hold back any longer and let's press play and get stuck straight into the lesson.
Mr. Moore's math class!
Good afternoon, guys, and welcome to Mr. Moore's online flip classroom. Now, I'm super excited today because we're going to learn all about how to apply the skills that we've learned, that is factorising, that is solving, that is the discriminant, and we're going to use these skills when sketching the graphs of quadratic functions. So let's have a look at how quadratic functions first of all look in a little animation that I just created.
Now, if you have a think back to what we learnt in the linear functions topic, what we've got is a whole bunch of dots along the x-axis. Now, I've chosen to put them at -5, -4, -3, but you've actually got millions of dots in between each one. Now, when we sketch graphs, what we actually have is just a pattern of these dots because it just tells us how high each dot needs to move up. So, for example, you can see the y equals 2x function here. What happens is I need to multiply all of my x values by 2. And what this gives us is how high each dot needs to move up along the y-axis in order to form the pattern. So if I put the x-coordinate of -5 into the function, that is y equals 2x, what I get is 2 times -5, which of course is -10. So what that does is it moves the dot from -5, 0, all the way down to -10 along the y-axis in order to follow the pattern. Doing the same for the x-coordinate of -4 now, what I get is 2 times -4, which is of course -8, so I get the dot at the point -4, -8. And following the same pattern now, I'll get -3, -6, -2, -4, -1, -2, 0, 0, 1, 2, 2, 4, 3, 6, 4, 8, and of course 5, 10. As you can see now, I've made a straight line. And as I said during the linear functions topic, what this line represents is just an infinite amount of dots just all joined up together to the point where it actually makes it look like a line. Of course, you wouldn't want me to go through and plot all of these dots because it would just take me forever and you've got better things to do with your time. So this is why we represent these dots with a line. So I've left this graph here just so I can go ahead and sketch the quadratic function, and you can see the differences between the linear functions and the quadratic functions after they've been sketched. That is a y equals x squared graph. So let's check that out. Now, as you can see, the linear function was a straight line, whereas the quadratic function that you can see now is more of a U shape. Now, why is that, you ask? Well, it's because when you square -5, you get positive 25. And when you square -4, you get positive 16. When you square -3, you get positive 9. -2 squared is positive 4. -1 squared is positive 1. 0 squared is 0. 1 squared is once again positive 1. 2 squared is once again positive 4. 3 squared is once again positive 9. 4 squared is positive 16, and 5 squared is positive 25. So when we square both the positive and the negative numbers, what we end up getting is a positive value for y. Also, what you might notice about this function is that in the middle of the graph, that is at the point 0, 0, it's rather quite flat, and what we call this is actually a turning point. Now, as you get further and further away from the turning point, it becomes steeper and steeper. Now, the reason for this is the squaring of the larger numbers. That is, the further you get away from the point 0 in either direction, the larger the impact it has, because when you square a larger number, there's a greater difference.
Shall we? Now we know what a quadratic graph looks like. It's extremely important that we know the steps that we go through in order to be able to sketch these functions. So let's check that out.
Okay, so today we're going to have a look at how to sketch quadratic graphs by using the intercepts method. Now, there's a few things that we must know. The first one being how to find the y-intercept. Now, like linear functions, what we need to do is we need to make x equal to 0 for this and find y. This will give us the coordinate 0 because we made x equal to 0, and whatever y value we happen to find. Now step 2 is to find the x-intercepts. Now to do this, first of all, we need to, like before when we were working with linear functions, what we need to do was we need to make y equal to 0 and solve for x. Now be aware, because if there's two types of x, what you need to do is factorize. Whereas of course one type of x that we've learnt before, all you need to do is use your BODMAS. And to solve you can either use the null factor law, completing the square, or the quadratic formula. And using this you're either going to get 0 intercepts, 1 intercept, or 2 intercepts. And they're obviously going to be in the form x value, and your y value will be 0 for each one of them. Now the next thing we need to know when sketching quadratic graphs is how to find the coordinates of the turning point. Now to find the coordinates of the turning point you're going to use this formula. That is, to find the x coordinates of your turning point you use negative b over 2a, and to find the y coordinate you use c minus b squared over 4a. Where of course you've got a general quadratic function with the formula ax squared plus bx plus c, where you get your a, your b and your c values from that. And step 4 is to determine whether or not the quadratic is a minimum parabola or a maximum parabola. That is, does the graph look like this? That is a maximum parabola, where the graph goes down to a minimum point, but then continues going up and up and up forever, for as long as x goes across. Or a minimum parabola, where the graph goes from a minimum point all the way up to a maximum point, but then forever, as far as you go across for the x value, it continues to go down and down. So here we have a minimum parabola, and we get this when our a value, that is a number out the front of the x squared, is greater than 0, or a positive. And we have a maximum parabola, and you get this when we have our a value being less than 0 or negative. So if you have a negative x squared, for example, it's going to go from a down point all the way up to a maximum point and then continue going down as you go along the x value.